Hello everyone. In this video, we are going to discuss Theorem 6.4, which is also known as SSS criterion for similarity, that is side similarity criterion for two triangles. See, we have already discussed about the first three theorems in our previous video, which is available in the playlist. So, according to this SSS criterion for similarity, you see, if in two triangles, sides of one triangle are proportional, that is in the same ratio to the sides of the other triangle, then their corresponding angles are equal. Hence, they are similar to, each other. That is, the two triangles are similar. See, this criterion which is stated here, that is actually referred to as side similarity criterion for two triangles. That is SSS similarity criterion for two triangles. Let us see the proof of this theorem. You see, here we are considering two triangles. One is triangle ABC, another one is triangle DEF. Okay, now we are considering these two triangles such that their corresponding sides are in the same ratio. That is, if in two triangles, sides of one triangle are proportional to the sides of the other triangle, then their corresponding angles are equal and these two triangles are similar. That is what this theorem states. So, we are assuming that these two triangles, we are considering these two triangles here and their corresponding sides are in the same ratio. So, you see, corresponding sides means for this triangle AB, corresponding to that, here we have DE. So, their ratio, that is AB by DE, is equal to, corresponding sides are in the same ratio. So, corresponding to BC, here we have EF. So, their ratio BC by EF, and that will be equal to, corresponding to this side AC, here we have DF. So, their ratio, what about their ratio? AC by or CA by DF or FD. I am taking it as CA. So, CA, or you can take it as AC, no problem. CA divided by FD. Okay, and you see, it is very clear from this figure that this DE, it is greater than AB. So, AB by DE, this will be less than 1. Similarly, BC by EF. You see, EF is greater than BC. So, denominator is greater than the numerator. So, this ratio will also be less than 1. Now, CA by FD. CA, FD. So, you see, FD is greater than CA. So, denominator is greater than the numerator in this ratio. So, this ratio also will be less than 1. Okay. Now, we are considering a line which is a dotted line drawn here, PQ. This line PQ cut this line DE into two, that is DP and PE, and also this line PQ cuts this line DF into two, that is DQ and QF, such that is we are considering this line PQ in such a way that this DP is equal to AB and this DQ, this length is equal to AC. Okay, we are considering a line PQ that cuts this line DE into 2 as well as this line DF into 2, such that this DP, that length is equal to this side AB of the first triangle, and DQ, that is equal to this side AC of this triangle. Okay, and here you see, when you consider this line PE, it is a transversal line, right? PE is a transversal line. Okay, PE is a transversal line. What do you mean by a transversal line? See, it is a straight line that intersects two lines at distinct points. So, you see this line PE, it intersects the two lines PQ and EF. Okay, see, when a transversal line intersects two lines, it creates a pair of corresponding angles. So, for lines PQ and EF, PE is a transversal line. So, the corresponding angles are angle P and angle E. So, these corresponding angles will be equal. That is, angle P will be equal to angle E. Okay, I'm taking this as 1. See, angle P is equal to angle E. Similarly, when you consider this line QF, see this line QF, this is also a transversal line. Because you see this line QF intersects the other two lines PQ and EF. So this line QF is a transversal line. Okay, it creates another two corresponding angles, that is angle Q and angle F. These two corresponding angles will be the same. So angle Q will be equal to angle F. I am taking this as 2. Okay, so you see, from the basic proportionality theorem, which we have discussed in our previous video, which is available in the playlist. From basic proportionality theorem, we have, if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. And here you see, here angle P is equal to angle E and angle Q is equal to angle F. Since these two angles are same and these two angles are same, it is very clear that this line PQ is parallel to this line EF. So we can write PQ is parallel to EF. Okay, so this line PQ is parallel to this line EF. Now from basic proportionality theorem, if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. So here PQ is parallel to EF. So we can write the ratio of these two sides, dP by PE, that will be equal to dQ by QF. Okay. And I'm taking this as 3. Now, let us inverse this equation, that is taking reciprocal on both the sides. So we can write it as PE divided by dP is equal to QF divided by dQ. Okay, now you see, from this figure, it is clear that, see, DE minus dP, that is actually equal to PE. So PE can be written as DE minus dP, okay, that is PE, divided by dP is equal to QF. See, in this figure it is very clear that what is this QF? DF minus DQ. Okay, so DF minus DQ, that is QF, then divided by DQ. Okay, now what I am doing is, you see this is like a common denominator, no? So I am going to put it for both the DE and DP. So we can write it as DE divided by DP minus DP divided by DP is equal to DF divided by DQ minus DQ divided by DQ. Okay. Now, this can be written as dE divided by dP minus dP by dP is 1 is equal to dF divided by dQ minus dQ by dQ is equal to 1. Okay, now what I am doing is, I am just taking this minus 1 to this side, it becomes plus 1. So we can write dE divided by dP is equal to dF divided by dQ minus 1. When this minus 1 is taken to this side, becomes plus 1. Okay, now minus 1 plus 1, that is equal to 0, no? These two get cancelled out each other. So we can write dE divided by dP is equal to dF divided by dQ. Okay, we are getting one such equation. Now, let us inverse this equation, that is taking reciprocal on both the sides. So, numerator comes to the denominator, denominator goes to the numerator. So, this can be written as dE by dP becomes dp by de, that is we are taking reciprocal on both the sides. We are just inversing these two equations. We are taking inverse of these two equations. Then df by dq becomes dq by df. Okay, so we are getting one such equation. Now let us consider this triangle DPQ, this one, and let us consider this triangle DEF. We are considering the two triangles in the same figure. One is DPQ, another one is triangle DEF. See, we have proved that angle P is equal to angle E, and we have proved that angle Q is equal to angle F. Okay, so these two triangles, that is triangle DPQ and triangle DEF, these two are similar by AA criterion. That is by AA similarity criterion for two triangles. That is, if two angles of one triangle are respectively equal to two angles of another triangle, then the two triangles are similar. Okay, so when you consider this triangle and this big one, you see this angle is equal to this angle and this angle is equal to this angle. So two corresponding angles are same. So if two angles of one triangle are respectively equal to two angles of another triangle, then the two triangles are similar by the AA angle similarity criterion. Okay, so we can say that these two triangles, triangle DPQ and triangle DEF, they are similar. So triangle DPQ is similar to triangle DEF. Okay, now we know that if two triangles are similar triangles, then their corresponding sides will be proportional, that is in the same ratio. So corresponding sides means, you see, for this triangle DPQ corresponding to this side DP, for the big triangle we have the side DE. So DP by DE is equal to, then I am taking this side DQ of the small triangle, then corresponding to this for the big triangle we have the side DF. So DQ by DF, that is equal to, for the small triangle we have PQ, corresponding to that for the big triangle we have EF. So this PQ by EF. Okay, these, since these two triangles DPQ and DEF are similar triangles, their corresponding sides will be proportional or in the same ratio. So we can write like this, which is taken as 4. Okay, now you see it is already given that in the theorem that the sides of the two triangles ABC and DEF, they are proportional to the sides of the other triangle. That is already given in the theorem. So corresponding to AB we have DE. So their ratio AB by DE, that will be equal to, corresponding to BC we have EF. So their ratio BC by EF, that will be equal to, corresponding to AC we have DF. So AC by DF or AC by FD, or AC can be taken as CA, no problem, which is taken as 5. Now you see, when we considered this line PQ, we already said that this DP, that is equal to AB and DQ is equal to AC. Okay, so by construction we have AB is equal to DP. Okay, AB is equal to DP and AC is equal to DQ. AC is equal to DQ by construction. Okay, because we have constructed one line PQ in that way. Okay, now I am going to apply this AB is equal to DP and AC is equal to DQ in this equation 5. So we can write it as AB is DP. So DP divided by DE is equal to BC divided by EF is equal to AC is DQ. So DQ divided by DF. Okay, or you can write it as DP divided by DE. Okay, this is equal to DQ divided by DF, and that is equal to BC divided by EF. Okay, I am taking this as 6. So we have equation 4 like this and 6 like this. Okay, now you see, from 4 we have DP by DE is equal to PQ by EF. Okay, from 4 we have DP by DE is equal to PQ by EF. Okay, and from 6 we have DP by DE is equal to BC by EF. DP by DE is equal to BC by EF. Okay, now you see when you compare the left hand sides, both are the same DP by DE, so we can equate their right hand sides. Okay, so we can write PQ by EF is equal to BC by EF. Okay, we are writing like this. PQ by EF is equal to BC by EF. Okay, see the denominators for both are the same EF, EF. So you can just cancel it. Okay, what does that mean actually? PQ is equal to BC. Or you can write BC is equal to PQ. I am taking this as 7. Okay. Now, let us consider the two triangles, triangle ABC and triangle DPQ. Okay, we are considering these two triangles ABC and triangle DPQ. See, by construction we have AB is equal to DP, AB is equal to DP and AC is equal to DQ. That is also from by construction we have AC is equal to DQ. Because we have drawn one such line PQ in this way, such that AB is equal to DP and AC is equal to DQ. Okay, and you see, we proved that BC, that is this BC is equal to PQ. Okay, BC is equal to PQ. So, these two are by construction we have. Okay, and this thing we proved. Okay, so by side, side, side. You see, AB is one side of this triangle, that is equal to DP, which is the other side of this triangle. AC, this side of the triangle, DQ, this side of this small triangle, DPQ. Then BC, this side of the triangle, PQ, this side of this triangle, DPQ. So, side, 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 no? All the three sides are the same actually. Like, corresponding sides are equal. So, by side, 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 congruence rule. SSS congruence rule, we can say that these two triangles, that is triangle ABC and triangle DPQ, they are congruent. Okay, so by SSS side, side, side congruence rule, we can say that triangle ABC is congruent to triangle DPQ. Then their corresponding angles will be the same. Okay, corresponding, that is by CPCT, that is corresponding parts of congruent triangles. We can say that if two triangles are if two triangles are congruent to each other, their corresponding angles will be equal. Corresponding angles means what? Corresponding to angle A, we have angle D here. So we can write angle A is equal to angle D. Okay, corresponding to angle B, we have angle P here. So, corresponding to angle B, we have angle P here. Okay, then corresponding to angle C, we have angle Q here. So, angle C is equal to angle Q. Now, in triangle DEF, triangle this big one, DEF, we have already seen that this angle P, that is equal to angle E, and this angle Q, this one is actually equal to angle F. Right, that is angle P is equal to angle E and angle Q is equal to angle F, which you have already proved. Okay. So now you just compare these two. Angle A is equal to angle D. Okay, angle A is equal to angle D. Then angle B is equal to angle P. That angle P is equal to angle E. So we can write angle B is equal to angle E. Then angle C, that is equal to angle Q. That angle Q is actually equal to angle F. So we can write angle C is equal to angle F. What does this actually mean? Angle A is equal to angle D. That means this angle A, that is equal to this angle, angle D. Angle A and angle D are the same. Angle B is equal to angle E. So angle B, this one, that is equal to angle E, this one. Angle C is equal to angle F, that is this angle is same as this angle of the big triangle. Okay, so all the three corresponding angles of triangle ABC and this big triangle DEF, they are the same. So we can say that triangle ABC is similar to triangle DEF. Hence the proof. Okay. That is, according to this theorem, if in two triangles, sides of one angle are proportional to the sides of the other angle. So, we assumed like that, sides of one angle is proportional to the sides of the second angle. Then, according to that theorem, their corresponding angles will be equal. So, that we have proved, corresponding angles are equal and the two triangles are similar. And this criterion is referred to as SSS, similarity criterion for two triangles, that is side similarity criterion for two triangles. I hope it is clear to you. Thank you.